Hello. In this video, I'm going to go over some changes I've made to the cell test box. Same general format or layout, but I have made a couple of minor changes to the controls and the placement of some of the components. And I wanted to review those and kind of go over a couple of different ways to test cells. So first of all, down on the main panel, previous one had a little toggle switch down here that you could turn on and off with. That's been changed. I've just added this little lamp here that lights up yellow while you're making high voltage. And now instead of the toggle switch, you just start and stop it with the run and stop buttons on the power supply. Same wiring layout. You've got a 110 volt plug to plug it in and power it. You've got a ground lead that clamps onto the cell. And then of course you got your high voltage lead that clamps onto the high voltage bushing or probe on the cell. Keep clear of the high voltage wiring while you're doing any tests, and try to keep it clear of any metal on the chassis. Another thing, the previous one had the display down here, and that one, when you were checking a bad cell, it could occasionally get some interference and cause the display to get jumbled, and you could lose the display and it would turn off sometimes. So to get that away from the inductive interference, I've moved this display up to the back panel, and that seems to keep it clear of any inductive interference. On that panel, you've got your mains voltage. That is the voltage after the step-up transformer. That transformer down there in the middle goes from 120 to 230 or 240. In this case, I'm getting 224 out of it. Just below that, get our wattage showing. The way I'm generally tuning these is to go up to roughly 400 watts on a good cell. That can vary depending on the condition of the cell. Gas pressure and things like that can alter that. Line frequency, 60 hertz of course. That'll display your amps that you're currently drawing at the 240 volt range. So keep in mind that does go up about double on the 120 volt side of things. And we do only have a 350 VA transformer in here, so it really isn't really designed to go more than about 2-3 amps on the 120 volt side for more than a couple minutes. So keep that in mind. Don't run this long term. Energy is not really useful for this application. Just happened to be one of the displays on this, or one of the values on this display. But if you ran it over time, it would tell you how many watt hours you're running. And then the power factor is just a factor of the efficiency of the unit. Again, this is just a test box, so that's not all that relevant. So the normal test that you would do, that I did on the previous one, is you just turn it on. You can slowly ramp it up with the potentiometer here from 0 to roughly 400 watts, and watch the display. On this display, you can see the resonant frequency that it's currently running at, and that does change as you turn power up and down. You can toggle through some different displays with the left or the shift button here. Cycles through some different displays like voltage, amps, frequency. Personally, I like the frequency one is the most relevant, because that one makes it really easy to tell if the unit is tuned properly for a given cell. So if you get a bad cell, that number doesn't work properly. It goes out of range. And of course, you're also looking at the wattage. So between the frequency on this screen and then the wattage on this screen, those are the two relevant values that you generally watch when you're trying to check for a bad cell. So that's the most common way, is just to turn it on, slowly ramp it up from 0 to full power on this potentiometer. If you're getting up into around 400 watts, generally means that the cell's okay. And if you're going to be somewhere around with this particular box, now the frequencies may change as we make modifications to the high voltage transformers, over time. But currently, as this sits, this one will tune to about 76 to 7900 hertz when you're running it at full power. As you turn down power, that number will go up. So at a low power range, it'll be upwards of 8500 to 9000 hertz. And then as you power it up, it'll drop. Another thing you can do, if you need to, if you push the escape button here, or program button, if you go to menu P24, use up and down, you can go through these. But if you go to P24, hit enter, this top right button, and then you go to 09. So P24-09, hit enter. If you change to 10 as the normal value, you have two choices, 10 or 11. If I set this for 11 and then hit enter, and then I hit escape to get back out of that a couple times. You can see I'm down to 1500 hertz. When I do that, the next startup for one cycle, it's going to do a sweep all the way from 1500 hertz. And what I've currently got this one tuned at is it'll go from 1500 hertz up to 9500 hertz, and it'll find the resonant frequency for the cell you're hooked up to. If you've got a known cell, like one of our OWS cells, that with this system would go up to roughly 8000 hertz, if it doesn't follow that same pattern and hit the peak at those frequencies, you can also detect a bad one. And also, as it sweeps past various frequencies, certain resonant frequencies may trigger an arc inside if there's a compromised enamel on the electrode. Let me hook up the air, and I'm going to do a demonstration going through this sweep. Okay, so I just hooked up air to my dryer. Pardon the mess, I'm doing this in my laboratory. I do have a little fountain pump just running some cooling water through this, but in a short test in the field, you don't necessarily have to have cooling water on, but you do need to have it purging with gas at normal cell pressure. I've got this one at about 35 psi, and then flow rate isn't that important. I've just got a very low flow rate. So now that I've got that on, and I've got this in auto tune, that's basically auto tune mode, and it's going to do a sweep. So now that when I turn this on, so turn up power to maximum, and then when I hit start, it's going to not, but so you can see it's sweeping through the frequencies. If you watch the wattage, when it hits certain resonant frequencies, you'll see a peak in the wattage. So we had a peak right around 3000 hertz. Now as we get closer to 7500 to 8000 hertz, you'll see another peak, and then it'll find that high resonant frequency. So you can see right now at running 6000 hertz, very low wattage, even though we're at max power. That's going to start climbing. So you can see it start climbing now as we start getting higher. Now we're getting close to 78. Now our wattage is climbing. Got up over 400. Once it hits 95, then it'll settle back down to the frequency that it. See, now we're at tuned frequency. So now it's settled back down to 7900 hertz. So if you had a bad cell, it would hang up at a wrong frequency, or it wouldn't finish that sweep and find a good frequency. When you want to stop the test, just push stop. Also, if you've noticed, when I had it on, the orange light illuminates on the panel. That's just to indicate that you got high voltage going. But now that I've turned it on a second time, now it's not doing that sweep. So it only does that sweep for one cycle of the power. Now I can just go to whatever power I want. See how as I turn it down, the frequency goes up. So those are two ways to do the test. The normal one, which is usually adequate, is you just turn it on and you run up the power and watch and see if you make power and the frequency fall. Test, if wattage does not climb to what is expected, or the frequency falls flat and doesn't go up, it usually goes low frequency on a defective cell generally. That's how you determine a bad cell. But a lot of it comes down to just listening to the cell, listening for arcing, and then watching the values. There is no lamp that turns on that says failed. You just need to know what you're looking for. So that's why I'm doing this video, so you'll understand what values are okay. And again, if you're doing the auto-tune sweep, it'll generally do a really smooth sweep all the way up to 9500 hertz. If it doesn't, it gets hung up somewhere, and when you know, or you start hearing some arcing, you'll know that that cell is not good. That one's failing. Got a bad cell hooked up now, and let's do a couple of tests on this to show you how the system reacts when you've got a bad cell. So this is the normal one where I just turn it on and ramp it up. So I activate it. I got my orange light. At low power, it doesn't really do anything dramatic. I'll start turning up the power. And we'll listen for it. This one, we got a pretty good arc going on inside of that. And you watch the frequency, and the frequency is going to go crazy. As I turn up the power, frequency is just plummeting. See that? And the wattage is all over the jumping around, it's low. See, I'm at maximum power now. I'm only making 39 watts. Frequency's down to 2700 hertz. So clearly a bad cell. Now let's try the method with the auto tune. So we'll hit program, go to P24. You can go up or down to get to it. Down is quicker if you're starting at 0. Enter, go to 9, change that to 11. Escape, escape. Alright, we set it for auto tune. Now we're at 1500 hertz is the low end of the spectrum. That may be a slightly different number, it's possible. The low end of the scale is fairly irrelevant. These things are, with this test box, are never going to run, you know, they're always going to be up around 7,000 or 8,000 hertz when in normal operation, but by doing a sweep, you know, we can enable it to perhaps test other cells. But so currently I've got it set for 1500 hertz. So now I've got it up all the way. This one is, I know, is going to fail, so, but in a normal test, you could just turn it all the way up and then see how it reacts. If it starts reacting and you know before it completes its sweep that it's failing, go ahead and hit the stop or the reset button. There's no need to let it finish. You just perhaps do more damage to the cell if it is salvageable, and there's no sense in putting an extra load on the test box if you know for a fact that it's failing before you even get through the full test. So we're going to do a sweep test. So let's hit run, and then we'll watch it go through the full sweep, and we'll listen to it. So at about 3,800 hertz, we're starting to hear it. Now we know there's kind of a dead band at the between 4,000 and 6,500 hertz. But that, once we get above 7, it's going to start, power's going to start kicking on again, and then we'll definitely hear it freaking out. There we go. Now we're getting our arcing. Wattage is falling down. See, now that it got done with its sweep, now it dropped down to the minimum frequency because we're getting arcing. It's clearly a failed cell, so that would give you a good indication. So the sweep is a nice test. We'll stop when we're done. See, that one found a resonant frequency for that cell at 1990 hertz, which is clearly way out of the range that we're expecting. So that's a indication that we got a failed cell. Again, give our tech support a call if you have any questions or need any assistance. 480-421-2400. Thank you.